PDF or PowerPoint presentation. So are you guys ready now to have the short discussion?
Yes, sir.
Okay. So again, we have already discussed this ACDC before. Okay, so this is just a matter of recalling the things that you guys have learned in electronics. Okay. So again, what is DC and AC? Of course, DC is the direct current that flows only in one direction, and then AC is an alternating current that flows in an alternating current or in two directions. So one is positive and then another one is negative. Okay, so here are the differences. So in terms of amount of energy that can be carried, so AC is safer to transfer over longer city distances and can provide more power. Okay, and then in direct current, yeah, voltage of DC cannot travel very far until it begins to lose energy. So that's the main reason why we're using AC, to our pose right now, to the our outlet right now. Okay, so yeah, that's why easy and not easy. And then it calls up the flow of direction of flow of electrons. So in AC, we have here a rotating magnet along the wire. And then in direct current, we just have steady magnetism along the wire. So in here, the magnet is the one that is rotating. So of course, wherever is that magnet going, the electricity will follow that magnet. So since it's rotating, of course, the electricity is also rotating. Okay, so that's why we have here an alternating current. But in here, we have a steady magnetism, which is just one. So that's why we have one flow of current only. So for the frequency, this one could be 50 hertz or 60 hertz. But for the direct current, since it's a direct current, of course, we have zero frequency for the DC. Okay. For the direction, of course, it reverses its direction while flowing in a circuit. And then in a direct current, it flows in one direction in the circuit only. For the current, so same is the current of magnitude varying with time. But in here, it's a constant magnitude. And then for the flow of electrons, so electrons keep switching directions from forward and backward, while in direct current, you only have one which is just going forward. And then this one can be obtained from EC generator and main electricity source. While this one in direct current, you can only obtain direct current if it's already in a cell or a battery. So it's already converted into DC current. For the passive parameters, we only use here impedance, and then for the direct current, we only use here our resistance. And then, of course, for the power factor, this one lies between 0 and 1, and then in here, it's just always 1. So we have here the types of waves. So we have sinusoidal, trapezoidal, triangular, square, so any kind of wave that can flow from positive to negative. Okay, but in here it's just pure all or pulsating. So of course, as long as that pulsating is still on the positive side. Okay, or vice versa. Could be also pure, but only on the negative side. Okay, so as long as it only has one uh, side. Okay, so if it's positive, that's positive. If it's negative, that's negative. Okay, so are we clear so far regarding with the differences?
Yes, sir.
Anyway, this one is very straightforward. So again, I'll be review this one later on. Okay, so here are the origins of AC and DC. So just like what I mentioned a while ago, when it comes to DC, so this one is coming from the battery. Okay, so DC, it says really this is how DC power from a battery was born. So initially it came from a magnetic field which is flowing in a single direction along the wire. Okay, that is actually the main reason why we have a DC current, because of a steady magnetic field. Okay, so if we have that steady magnetic field, it'll come up or it will give an output of a DC current or DC power. Okay, while in AC, so if we have a steady magnetic field right here, in here we have here a rotating magnet. So this one is worked by a famous inventor, which is Thomas Edison. So one of our idols, one of the foundation when it comes to uh, electricity. Okay, but this scientist right here, Nikola Tesla, come up with the rotating magnet. Okay, which is there's actually a debate right here before we're in which one is better, DC or AC. So there is even a time that Thomas Edison saying that DC is a lot safer than AC, but uh, after maybe I don't know, maybe a month or a year of a debate, they have proven that AC is actually safer than DC. Okay, because this is constant, and then AC is alternating, and it's safer in carrying this one in a longer distance. While in DC, it's much more dangerous. Okay. Anyway, so again, if it's DC, we have a steady magnetic field. And then if we have AC, we have here a rotating magnet. So that is where the came from, okay, or that is their main source that they were coming from. So rotating magnet, it's AC. It will give you an output of AC. If it's a steady magnetic field, then it's a DC output. Okay. Now, if you want to see a comparison between AC and DCs, you can watch this video right there. So if I'm not mistaken, this is a 5-minute video. So just check this one out later on. Okay. So just the short introduction with this pulsating, direct, and then variable, and then alternating. So of course, this straight line right here is a direct current, and then the green one is the alternating. So positive, negative, positive, negative. It's alternating. And for the pulsating, we have here just positive. So yeah, it's current, or the amount of electricity is changing from time to time. Let's say from 7 to 8, 7, 8, 7, 8. So it's pulsating, but it's still in one direction. I mean, it's still in a positive direction. So we can still consider this one is a DC current, but not a pure DC. Okay, because it's changing its value from time to time. Okay, and then we have here a like freestyle, like in this one could be just negative, this one could be just positive. So we don't know it. It doesn't have the pattern. So let's say -2, negative 1.5, and then we'll go to negative 1.8, and so on so on until it reaches now the positive, let's say +2, +1, positive 1.5, and so on and so forth. So we call that one variable. Okay. Anyway, so let's go over to the use of transformers with alternating current. Now, to make it short, in every pose that electricity pose that we have, it has a transformer. Okay, the goal of that one is to amplify or to strengthen the electricity that's being delivered on that post. So if that is just a post wherein the wires is connected, it's just holding the wire, then there is this time that of course that AC will lose its power. Okay, let's say from 1,000 volts, it will become 500 volts. So, right, sorry for that. Okay, so yeah, that's the main goal of a transformer. Okay, so each battery is designed to produce only one voltage, of course, and that voltage of DC cannot travel very far until it begins to lose energy. Okay, so again, that's the main advantage of DC. But AC's voltage from a generator in a power plant can be bumped or down in strength by another mechanism called a transformer. So you could say that this one is a step up transformer or a step down transformer. Of course, if it's a step up, it's bumping up the electricity. If it's the step down transformer, then it's bumping down the electricity. Okay. Anyway, so the transformers are located on the electrical pole, okay, on the street, not at the power plant. Okay, so we could say that this is an amplifier or the opposite amplifier. Okay, so we change very high voltage into a lower voltage appropriate for your home appliances, like lamps and refrigerators are only using 220 volts. So of course, from the power plant, it's maybe 1,000 volts, 5,000, 1,000. Okay, and then it will be distributed in all of our electrical pole. And once it reaches our, maybe our electrical pole in the front of our house, which is where our electricity is connected, where the main source of electricity is connected. So the one that we're receiving on that transformer is just 220 volts. Okay, though it's still easy, of course, that pure 220 volts. So from time to time, it goes to negative 220 and then positive 220. But yeah, of course, it's very, very fast in just a millisecond or nanosecond. Okay, so are we clear so far regarding the transformer?
Yes, sir.
Just let me know if ever you guys have a question, okay? And then storage and conversion from AC to DC and vice versa. So AC can be of course changed to DC, and then vice versa, DC can be changed to DC by an adapter that you might use to power the battery on your laptop. So DC can be pumped or down. It's just a little more difficult. So inverters change DC to AC. For example, for your car inverter, would change the 12-volt DC to 120-volt AC to run a small device. Well, this you can store it in batteries. You cannot store in AC. Now, going back to your electronics, so if we have inverter, to change or to convert a DC to AC, what is that thing that we call again in order to convert an AC to DC? Anyone? What is the term for that converts AC to DC? Anyone? All of you are already done with
Sure. Sir, do you call it a rectifier, if I remember correctly?
electrifier.
Rectifier, sir, not
Yeah, rectifier. That's the word.
rectifier. Okay.
Rectifier. So thank you so much, Mr. Ryan. So that's correct. We call that one rectifier. Okay, so we have let's see, halfway. We've started with halfway, just changing that AC into one side, either positive or negative, and then we have the full wave rectifier. We even have the bridge rectifier. Okay, and yeah, those are the types of rectifier to convert in AC to DC. Okay, so your goal in here is to figure out, some circuit read, okay, on how to convert DC to AC. So I need you guys to do that one on your LP Spice. Okay, it is one. Okay, so any circuit will do as long as it's proven that I have an DC input and then AC output. Okay, so I hope we're clear with that one. So here's the steps to convert AC to DC. We actually have 4 steps or 4 different ways, okay, to convert AC to DC. So we can use electrical power supply, wherein of course it's using 220 volts to 220 volts 630 AC supply, and then it will convert it one into a pure DC, say pure 220 volts or pure negative 220 volts. Okay, so this one could be step down or step up converter. So depending on the power supply. So there's a lot of there's a lot of kinds. So depending on what you need or how much you need, okay, that power output that it can give you. But yeah, most cases from 220 volts it will give you 5 volts. From 220 volts it will give you 12 volts maybe, or from 220 volts it will give you 24 volts. Okay, so that completely depends on the system, okay, or the need of your system. Okay, so we also have here this one's still power supply, but yeah, so here what's the most important thing that we need to talk. Maybe this one. So I highlighted this one. So it says here that hence this circuit can be called as a power supply circuit, and there are various types of power supply circuits such as switch mode power supply, variable power supply, and then DC regulated power supply. So mostly we have this DC regulated power supply. Okay, so it converts that one, just from 220 into 5 volts. Okay, and if you need a variable power supply, like you can change the value of the DC output, okay, from time to time, then you can use this variable power supply. Or if you want an automated one, like the switch mode, like if you switch this into let's say it has one switch only. Of course, one is let's say for 5 volts, and then another one is for 10 volts. Okay, depending on the the preset, okay, the one that's being set on that switch mode. Okay, so yeah, 3 types for the power supply circuit. So I should have changed this one into types of power supply. Anyway, so yeah, those are the different types or a classification of the power supply. So in laboratories, of course, we have a variable power supply. So we can change that one into, let's see, 1 volt only, 2 volts, 3 volts, 4 volts, up to maybe 24 volts. So that's mostly the highest variable value when it comes to DC supply. Okay. So we also have here AC to DC. Again, we call it one rectifier. So I will not be discussing this one anymore since we have discussed this one in electronics. So yeah, just recall the term rectifier. And then we have here 4 simple steps. So here are now the different ways on how to convert an AC to DC. So first, we have here stepping down the voltage levels. So again, this one is the transformer. It could be step up or a step down transformer. Again, from 230 volts or 250 volts, rather since here in the Philippines, we're using 220 volts. But the source where I've got this one is maybe they're using 230 volts. Maybe this one is from Europe. Yeah, 230 volts. That's the one that you're using. But here, 220. So it could be from 230 to 12 volts, 230 to 17 volts, or depending on that converter, of course. So, of course, there are 2 windings in the step-down transformer. So, in here, we call that windings like a ratio and proportion. So, sometimes it's 1:2, 2:1, 3:2. So, that depends. So, if we say 1:2, so from 1, it will be amplified into 2. Okay, so let's say from the input is, let's say 12 volts. Okay, and then since it's 1:2, then it will be doubled. So from 12 it will become 24. Or if you have a step down transformer, so you have, let's say 2:1, okay, let's say 12 volts, it will become 6 volts. Okay, so yeah, those are the only differences of a step up and step down. And then the term windings. Okay, so later on you will see here. Okay, so this is an example of a winding. So mostly we have a ratio and proportion right here. Let's see, 1 for this one and then 2 on the other side. So if it's something like that, then it's amplifying your voltage. Or if it's the other way around, let's say 2:1, then it's let's see, from amplify to do the opposite. Okay, so it will lessen the voltage. Okay, or it will divide the voltage into 2. Okay, so again, more explanation on what's happening with step up and step down. So from 230 volts it will become 17, 230 volts it will become 12 maybe. Okay, and then we also have BC to DC. Where is that one? I think it's still not here, but yeah, I think it's around right here. But yeah, maybe we'll be over to discuss the DC to DC, but I think it's not on this slide yet. So let's move on. So we still have AC to DC, which is a bridge rectifier. So more explanation on how to convert AC to DC. So we will not discuss this one anymore since we have already discussed bridge rectifier in electronics. So you guys already know that one. And what else? So more explanations about the connectivities, the configuration of the diodes. Okay, this D1, D2, D3, D4, and then the computations maybe and how you will get 12 volts or 17 volts. Okay, third one is obtaining pure DC from pulsating DC. This is not the one that I'm talking about. So we have AC to DC, we have DC to AC, but we also have DC to DC. Okay, so you can actually, from DC, you can still convert that one, or should I say amplify or step down that voltage. So let's say you wanted to step up that 12 volts, so you can make that one 24 volts. Okay, without converting that one into AC and then DC again. So you can go straight to DC to DC. So in here, we just use filter. So we have different kinds of filter. Right here we have inductor, capacitor, or even a coupled filter. So a resistor and then a capacitor can be used to remove the ripples. Okay, so in here it will still give you the same output. Okay, or you can have a pulsating DC instead, okay, into a pure DC output. So yeah, this is still under a direct current because this is in one side uh, or a one sign voltage only, and then still in one sign, but it's now a straight line or a pure DC output. Okay, so yeah, are we clear so far regarding with this one from pulse heating to pure DC?
Yes, sir. Gets one.
Yes, sir.
Okay, so if ever you guys have a questions, just let me know. Okay, so we still have 5 minutes left, so I guess we can still finish a few more slides. We also have here regulating DC voltage. So the 15 DC output voltage can be regulated DC voltage regulators such as this microchip, okay, IC78 XX. So we have different numbers right here, but yeah, as long as it's 78, so it's already a voltage regulator. It's just that we have different kinds of regulator, okay, in which the last two digit XX represents the output voltage value. So if you need, let's say 12, then just change this one into 7, 8, 1, 2. Okay, so that's what you need, then you have to buy that specific IC. And if you need 24 volts, maybe DC output, then change, just buy a specific IC, which is 7, 8, 2, 4. So depending on, again, the system that you'll be needing. So here, let us consider the IC7805. So it's already obvious. So we need a 5-volt output, so which is used for maintaining constant 5-volt DC output, even though the input is varying DC voltage, let's say from 7.2 to 35-volt DC. So this one, as you guys can see, we have here a pulsating DC. So it keeps on changing from 7.2 to 35, 7.2 to 35, and so on and so forth. And then you just need a pure DC. So you have to use IC7805. Okay, so here is the voltage regulator internal diagram of an IC. Okay, wherein this one is the variables depending on the again the voltage that you'll be needing. So we have here the starting circuit, current generator, reference voltage, and so on and so forth. So here you will see the input, the ground, and then here's the output. Okay, so this one is quite hard to read right now since yeah, you're not that familiar in 7805. But once you saw maybe an actual IC of this one, and you will appreciate that it just has 3 pins. Okay, so this is the input, and then the ground, and then the output. Okay, wherein you have an input of this one 7.2 to 35, and then ground is ground, of course, it's just 0 or negative pole, and then the output will just give you a constant 5 volts. It's saying here that this is the parts of this IC right here. Okay, so again, the above figure represents a block diagram of IC7805 right here, this above diagram. DC voltage regulators, it consists of an operating amplifier that acts as an error amplifier. So a Xenodie which is used to provide voltage reference as shown in the below figure. Okay, so we have here the voltage input, so one resistor, and then a Zener diode, which is limiting the voltage output into 5 volts only. So yeah, you can have this concept also like an it says here an error amplifier. So what is that error? So once it receives, let's say 7.2 or 8 or 10 or 15, those are actually errors. So it only gives you one constant output, okay, which is the 5-volt DC. Okay, so yeah, that's the logic behind this circuit right here. So Zener diode as a voltage reference. So the series pass element transistor is used to dissipate extra energy as heat, and heat sink can be used for thermal protection. So I hope I'll be clear with this one. This is the continuation of this regulating DC voltage. So this is one example that can be shown in our spice. So again, a full wave rectifier. So if I'm not mistaken, I have already shown this one to you guys in our electronics. But yeah, from AC into a DC output, wherein we only have one output, which is the positive output. Okay, so we also have the full wave rectifier with RC load. So from pulsating DC from 0 to let's say 5 volts, so we can maintain a voltage of let's say 4 to 5 volts. So it's still has a little bit of ripple. Okay, so it's still pulsating DC. Okay, but it's already lessened with the use of resistor and then a capacitor. So let me see, we still have 1 minute left. Okay, so we'll stop here for now, and then we'll just continue the rest on the next part. So if ever that you guys have a question, so just let me know on the part 2. So goodbye for now, and then see you guys later. You can continue now. So let me just check. So can you guys give me thumbs up real quick? So I know that you guys are already in front of your computers. Wait. Okay. So did I share my screen already? Yeah. So where did we start? Right here. All right. So are we clear so far regarding with this one? So we call this one full wave rectifier with RC load. Okay. So we have here the load, the resistance, and then the capacitor. Okay, this is where we are reading the V out, wherein it will give us a ripple voltage. So are we clear? Any question regarding with this one?
Wala naman na, sir.
Those who have experience doing this one in electronics, then you guys already know how to do this one or the output, expected output of this one. Okay. Now we also have this kind of AC to DC converter, which is using a transformer. So as you guys can see right here, we have here the two inductors. So we have L1 and then L2. So in order for you to make this one as an official transformer, you have to configure this one in Spice. So like for example, this one. So we have the sine wave 0, forget the first one, but yeah, mostly it's 0, and then this is the voltage, and then this one is the frequency. So 5 volts, 50 hertz frequency, and then the R0 is equal to 0.1 m k L1, L2, and then 1. So this is the configuration that you need to do in order for you to have a transformer. Okay, and then the rest are pretty normal. Okay, we have 4 diodes, silicon diode, and then 1 resistor right here, or the load resistor. Okay, so in order for you to configure this one, so I'll go over with this one first. So yeah, the first one is DC offset. So since we're dealing with AC, so it should be 0, of course. So amplitude is the AC value, okay, which is 5 volts only, and the frequency is 50. Okay, and if I'm not sure if I change this one in 0.1 m, so we have a series resistance of 0.1 m, okay, 0.1 mega ohm or milliohm. Okay, I I'm not really sure with this one anymore, but yeah, just change it one into 0.1 M. I think this is milliohm, okay, not megaohm. Anyway, so yeah, that's it for the uh, AC input. And then we have here the configuration of your transformer. Okay, so in here you have to add the schematic or the this one, the L1, L2, or the transformer itself into KL1, L2, 1. So K is the, what is this one again? If I'm not mistaken, this is the term for transformer. So I forgot already. But here is a complete guide on how to come up with this uh, transformer configuration right here. This one, case statement is coupling the windings. So meaning you are already combining these two inductors into two, which is having as a result of a transformer. Okay, so as I can see right here, we have a ratio, what which is 1:3, wherein of course from 100% it will be tripled. Okay, so it will give us an output of 3 times of your input. Okay, so yeah, that's basically it for this transformer. Or you can have, let's say, of course, uh 3:1, or that depends on the one that you will be needing for your output. Okay, if it's a step up, then just amplify it. If it's a step down, then just uh change the ratio into 3:1. Okay, all right, so are we clear so far regarding with this one? Well, maybe just the concept, but for this one, you guys have to experience in doing this one in real life or in LT Spice. So again, I highly recommend you guys, or I highly require you guys to be visit this website right here. Okay, so this is the complete guideline on how to come up with this transformer. Okay, so just check this one out. Okay. So for now, we have here the sample voltage input and output without the capacitor. So if without the capacitor or without the filter, so we still have the complete ripple. Okay, so green one is the AC, and then the blue one, is it blue? It seems like violet to me. Anyway, let's just see that this is blue or violet. So this is the DC output. Okay, so it's the pulsating DC from 0 volt to 6 volts, 6, and so on and so forth. And then if you will add 10 micro farad capacitor right here, so you'll be able to lessen the ripple. So before, from 0 to 6, it will become just 0 to 6, and then the following reading will become like 3 or 4. So 6 4 6 4 6 4 6 4. So you were able to lessen the ripple voltage as well, just by adding a capacitor. So we could say that capacitor is like a smoother, okay, to make it more smoother, or to make it more a pure DC output. Okay, and then if we change the value of the capacitor into 100 microfarad, then we can have an output of, let's say, 6 to 5.5, 6 to 5.5, 6 to 5.5. So it's now almost a straight line. Okay, so this one is already considered as a pure DC output. But if you're a perfectionist, then you can change this one into a higher value of capacitor. Okay. Well, I just have some theory right here. So why happy rectifiers are generally not in use in DC power supply? That's because with the happy rectifier, the output voltage is 0 for half the time. Okay, the type of supply available from happy rectifier is not satisfactory for general power supply. Okay, that is why it is generally not used in DC power supply. If possible, we want to attain something like this. So if not, almost a perfect DC output, a pure DC output, which is purely, let's say, 6 volts only. Okay, so here are my references for this PowerPoint presentation, and yeah, that's it for the ACDC. So, are you guys able to understand everything so far? Hello, are you guys still around? So any question or clarification regarding the AC to DC module?
Wala naman sir, gets naman nata. Kasi sir, since di ba parang na-brief na natin yan nung sa electronics natin.
Yeah, that's right. Okay, so there's really no question. So again, if ever you have a question in the future, so just message me on my Canvas or on my Facebook account. All right, so the last module will be EC to EC2. So this is just a 11 slide. Well, in fact, this is maybe 9 slide because the last is the reference and then the end of PowerPoint presentation slide. Anyway, so again, what is a DC to AC converter? So it is an inverter wherein it's converting our DC into an AC supply. Okay, so let's see what is the thing that we need to discuss right here. So yeah, this is one thing that you guys need to remember when it comes to DC to AC. So we call that one inverter technology. Okay. And generally, they operate with 12 volts and commonly used in applications like automotive, LED, acid technology, or photovoltaic cells, or etc. But mostly, we have inverters in, I think, if I'm not mistaken, in washing machine. Okay, to see more energy, or it's recycling the electricity that's receiving, let's say from the rest are converted, the extra are converted from DC, and then it has the ability to convert that one into AC for it to use the AC power. Or we always, or we, yeah, I think in all of the cars, this is what we have, from a battery into a AC, okay, power. So yeah, we charge our phone, right? Okay, of course, it need the an AC output. Okay, so of course from AC it will be converted to DC again, since it has a converter inside of that battery brick. Okay, so yeah, mostly that is where we use that DC to AC. So it's coming from our battery, okay, battery of our car, and then it will be converted into an AC. Let's see, 120 volts AC or 200 volts, depending on how much energy you need. Okay, so a transformer, call system, and a switch is the simple circuit used for an inverter. So we have a transformer, and then we have a switch for that one. So in AC to DC, we only have transformer. But for the DC to AC, we have two. So we have transformer coil system and then a switch, okay, for the inverter. So a typical transformer can be connected to wire the DC signal input through a switch to oscillate back quickly. So due to the current flow in bidirectional in the primary coil of the transformer, an alternating current signal is an output throughout the secondary coil. Okay. Well, I guess this one is quite ambiguous for now, but let's move on for you to be able to understand what's really happening on how to convert DC to AC. So DC to AC converter circuit using transistors is shown on the right. So this one is now using, this is another type of circuit, which is using a transistor to convert DC to AC. So yeah, this one is quite complicated to understand, but yeah, here is the battery, which is the original source of your energy. And then we have here the step-up transformer, and then the switch. Okay, so yeah, I know that it's quite complicated. We have resistors right here. We have capacitors right here. Okay, we even have like the NPN or the PNP transistors right here, the 2M222. We even have IRF630, which is another kinds of transistors. Another IRF630 right here. But yeah, here are the things that you will need if you're going to use a transistor as a converter. Okay, of course, it still needs a step-up transformer, not just a resistor, capacitor, and then the transistor. Okay. Anyway, so yeah, this one is your way in order for you to convert your 12 volt DC into a 220 volt AC converter. Okay, with using simple transistors. It says here simple, but for me, it doesn't look simple in this kind of circuit. Okay, so the inverter executed in the circuit can be a square wave, and it works with devices like which do not need pure AC sine wave. So if you have pure DC, just take note, we also have pure AC sine wave. So what are those not pure AC? If it's not the sine wave, then like for example, square wave, what else? Different kinds of wave. Uh, forgot the other term, but yeah, we only have one pure AC, which is the sine wave, and then the square wave, and then the others are not a pure AC. Yeah, AC wave. Rather. Okay, so I was about to say sine wave. So just remember that if it's pure AC, then it's sine wave, and then the rest are not pure AC anymore. Like for example, square wave. So here are the required components. So we have here MOSFET, transistor, capacitor, resistors of 12K, two resistor of 680 ohm, and so on and so forth. Okay, for those components that you'll be need if ever that you want to do this one in LD Spice. Okay, so here is a working circuit from DC to AC circuit can be separated into three portions, namely the amplifier, transistor, and then an oscillator. So as the AC supply frequency is 50 Hertz, then a 50 Hertz oscillator is used. So of course you can change this one into 60 Hertz since here in the Philippines we're using 60 Hertz. So if you need 60 Hertz, then you have to use an oscillator which is also 60 Hertz. So this can be attained by designing unstable multi-vibrator. Okay, so search just one on the internet on how to design a stable multi-vibrator. So this one, I will generate a 50 Hertz square wave signal, and then the oscillator can be formed using the resistors like R1, R2, R3, R4, and then capacitors like C1 and C2, and transistors like T2 and T3. Okay, or you can sometimes you call that one L1 and then L2. It's like what we have. My apologies. This one is transistor, not inductor. So yeah, this one is correct. My apologies on that one. So it's T2 and T3. So every transistor generates square waves, inverting, and the frequency will be decided by the resistor and the capacitor values. So the frequency formula for the generated square wave with the stable multivibrator is F is equal to 1 divided by 1.38 times R2 times C1. Okay, so it's just the formula for the frequency. Okay, so what will you come up with 40 hertz? Do you need 60 hertz? Do you need 30 hertz? So yeah, just come up with the correct values of your R2 and then C1 in order for you to get the correct frequency that you'll be needing on your system. And then the oscillator inverting signals are improved with the two power MOSFETs such as T1 and T4. And these signals will give to the step-up transformed by its center tap associated with 12 volts DC. So in other words, this one is the explanation and how to set up the values for your converter, or this one with the use of MOSFET, transistor, and then resistor. Okay. So here are some limitations of DC to AC. Of course, if you're going to convert DC to AC, it has a disadvantages or cons. So the transistors usage can reduce the circuit efficiency. Okay, so that is one thing that you guys need to take note of. Okay, or be familiarized with if you're going to convert a DC to AC. So the usage of switching transistor can cause a crossover distortion. So within the output signal, so we have this distortion. However, of course, we have solutions with this distortion here, but this limit can be reduced to some level by using bias inductance. Okay, so yeah, it already has a solution on how to solve this distortion if you're going to come up with this DC to AC converter. Anyway, see, here are some applications of DC to AC. So we have here, of course, the number one is this one is used in vehicle to charge their batteries, DC to AC. and then mainly used for driving low power AC motors and used in a solar power system. Okay. Thus, this is all about DC to AC converter. This can be used in DC transmission lines for transmitting power to loads in uninterruptible power supplies. So this can be used to convert direct current to alternating current, and converters can be used in industries where consistency is the problem. So if you need maybe the other way around, wherein it says here converters, uh, where is that one? Yeah, converters can be used in industries where consistency is a problem. If in your area, the consistency of AC is a problem, like if you really need a consistent value of, let's say, negative 220 to 220, so you can come up with your own machine or with your own converter. Okay, like you need to convert everything in DC first, and then from DC, you can have a AC supply. Okay, so of course with the use of UPS. Okay, this uninterruptible power supply. Though this one is quite expensive, like maybe three for let's say PC, which can store I'm not really sure with the kilowatts, but yeah, let's say it can run your laptop for 30 more minutes, 30 to 1 hour. So that's already maybe 3,000 peso to 5,000 peso. So yeah, just in case that you need that kind of supply, let's say to a certain situation, but I cannot, until now, I cannot think of a situation wherein you'll be needing to convert the AC to DC first and then use that one from DC to AC. Okay, but that is one example. Let's say you need to use that one on your laptop. Okay, so of course you're going to buy UPS in order for you to store that one into AC. Okay, from DC to AC, and then use that AC into something else. Okay, so yeah, those are some applications on why we convert DC to AC. Okay. But of course, there's a lot more examples out there why you need to convert DC to AC. But of course, mostly we don't convert DC to AC because we can already have the AC power in our outlet. Okay, so that is why DC to AC is very uncommon. Okay, since originally we already have the AC, unless you want to have a double conversion. So AC to DC and then DC to AC, which is very, very impractical. Anyway, so why do we require changing from DC to AC? Again, most of the vehicle, again, this one is mainly used for in our cars. Okay, so of course we don't have that outlet. Okay, we don't have that connection to the electrical pole. Okay, wherein our car has an outlet of 220 volts. So we use our DC voltage and then convert that one into AC voltage. This to come up with a 12 volt my bad, my apologies. Just come up, let's say, with 120 volt AC voltage. So going back here, most of the vehicles use their powers from a battery 12 volts, but in some cases, a 24 volt battery can be used also. So it is very significant to know the vehicle voltage due to the voltage rating of the inverter we choose must be equal the battery's voltage. So in any case, the battery gives DC, which means the flow of current will be continuous from the battery's negative terminal to the positive terminal. So in DC, the flow current will be only in one direction. Thus, DC is extremely helpful. However, batteries can be normally provide somewhat DC power with low voltage. So several devices require extra power to work correctly than DC can offer. So thus, this is all about DC to AC converter, how to convert DC to AC. Converter enhances the DC voltage to alter it into AC before transmitting it out to give current to a device. So primarily, these were intended to perform the reverse for converting AC DC. Because basically, these converters could be worked in opposite chips to reverse effect. So this is called as inverter. Okay, so like more concept or why we need this DC to AC conversion. And yeah, we have two types of converter. We have the voltage source converter, and then we have the current source converter. So from DC to AC, from DC to AC. If you need to convert the voltage from DC to AC, so you'll be needing a capacitor for this one. Okay, and it's parallel with our voltage input. And then if we need a DC current, let's say DC power current into a AC current, then you have to use an inductor, which is now in series with our voltage input. Okay, and yeah, here's another sample circuit of a DC to AC inverter. So we have here four diodes. We have four silicon diode. We have the resistance or the RL couple. Okay, and yeah, we have here the inputs, and then we have here the there's one capacitor. If I'm not mistaken, VDC divided by 2. But there is no label and this one is capacitor. But this one is a symbol of a capacitor, and then it's the same here that the voltage output will be divided into 2, and then once they are combined, then we have here now AC output, if I'm not mistaken. Oops, my apologies. This one, why we have DC to AC right here, but in here we have AC to DC. Let me just check real quick. I don't know if this is a typo. Supposedly this one is DC to AC since we are in DC AC.
DC to AC converter. Rechargeable batteries are the best option to store electrical
Wait a second.
energy,
So
especially
my
to backup
laptop
power
just hung.
warehouses.
But yeah, this one is
We know
DC
that
to
the
AC.
electrical output
So
of
this
batteries
one right here is a typo. Okay, my apologies with this one. This one is DC to AC. Okay, so this one is the sample circuit of a DC to AC, not AC to DC. Okay, so you will see here that this one is also DC to AC. Okay, so yeah, one more thing, another term for inverter is called converter. Right. Anyway, just check this video later on, which is explaining this sample circuit like this. And yeah, that's it for this video. I mean, for this presentation. Got it. So here are my references, and then yeah. So that's all for the ACDC and then DC to AC. So any question or clarification so far? So while I'm waiting, let's just edit this one so that I won't forget anymore that this one is DC to AC. Question, guys, or clarification? DC to AC. So were you guys able to, it's having an error since we are using the file. So were you guys able to follow everything?
Yes, sir. Understood now.
Okay. So
Yes,
again,
sir.
just a reminder. Let's go back right here again. Number 8 is DC to AC. So this is your main goal actually, and how to come up with that circuit. So this is the main challenge of this laboratory because AC to DC, AC to DC is like a bonus already. You already have a lot of examples on how to convert AC to DC. Okay, but still, you guys need to do this one for your 9th laboratory. So the only challenge is the DC to AC. So make a working circuit on all these files and how to convert DC to AC. Yes, you can search on the internet for more information or for more tips on how to do that one on all these files. Okay, so yeah, that's it for now. And the due date of your 8th and 9th lab will be on, so I haven't edited this one yet, but yeah, it will be due on February 4th. So you guys have exactly 2 weeks from now So the same with your case study. So if you guys don't have a question anymore or clarification, then I guess it's already it. As usual, thank you guys for coming. I really, really appreciate it. And then again, my apologies with my voice since I don't know, maybe this is the after effect of my cough. I don't have the cough right now since I'm already good, I guess. Hindi naman ako inuubo. Pero yeah, I don't know. But my voice stays as it is. As, you know, in last few days, 3 days ago, ganito yung boses ko, parang ang lalim. Anyway, so goodbye. And yeah, let's just meet again next meeting. So goodbye and thank you guys for coming. And keep safe.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you, sir.
Sir, question, sir.
Yes.
Sir, about dun sa soft design. Sir, yung sa lecture subject ba tsaka dun sa ano sa lab subject? Sir, pareho ba yung dapat na plan or magkaiba sila? Yung para dun sa title proposal, sir.
Legal proposal. Sino ba yung lecture mo? Ako?
Sir, kayo rin, sir.
Lab. Tapos lab ako din.
Yes, sir.
Because my plan in here is in lecture, it's just pure lecture. Meron bang title proposal sa lecture?
Hindi, sir, yung sa SLDC model, sir, yung by group.
Hindi. Kahit iba yun. Kasi that's just for the sake of activity. You can just have one e-commerce, right? And then you're going to just do best SDLC method that you think is best fit on that e-commerce. So any will do as long as you were able to, explain why that is the best methodology for that e-commerce. And then for the laboratory, you have to very careful on that one since that is the, kung ano man yung pre-propose nyo, yun na yung magiging final project nyo.
So, for example, sir, like we want to create an app, ganun ba, sir? Parang yun yung sa lab, pero yung sa lecture is iba na, parang e-commerce na.
Mga activities lang yun and then just the concepts. And then, yun talaga yung final project nyo will be on laboratory. Okay.
Okay. Thank you, sir. Thank you for clarifying that, sir. Share ko na sa team ko. Thank you, sir. Bye, sir.